The entire universe appears to be governed by a fundamental dynamic of continuous oscillation between order and chaos. To clearly understand this dynamic, let us begin with a simple and familiar phenomenon: the classical harmonic oscillator, such as a mass attached to a spring. This system continuously oscillates between two forms of energy: maximum potential energy at the extremes, a state of order, maximum stability, and maximum kinetic energy at the center, a state of chaos, maximum change. Yet this seemingly simple phenomenon reveals a much deeper truth. If we examine the equations that precisely describe this classical harmonic oscillator, we find that they are exactly the same as those that describe the quantum harmonic oscillator, provided we use a more sophisticated mathematical formalism, namely that of quantum mechanics. This apparent sophistication, involving complex numbers and exponentials, serves specifically to reveal the fundamentally oscillatory nature of reality, deeply linking the classical and quantum worlds. In the quantum universe, the system's fundamental stable state is described by a spatial Gaussian probability distribution, with the highest probability exactly at the center, at the point of stable equilibrium. Thus, quantum temporal dynamics, oscillating between ordered coherent states and chaotic superpositions, spontaneously generate this stable spatial probability distribution. This profound link between temporal dynamics and stable probabilistic distribution is precisely accounted for by the fundamental quantum principle of least action, developed by Richard Feynman. This principle simply states that nature spontaneously explores all possibilities in order to naturally select those that minimize the system's overall action. Thus, our universe clearly appears as a vast fractal quantum oscillator. Each extreme state carries within itself the seed of its opposite, and each transition between order and chaos generates a new branching of possible universes. This fractal structure of the multiverse, where each quantum measurement opens an infinity of new possible branches, ensures perpetual reorganization, an infinite dynamic balance between stability and change. This fundamental fractal dynamic, which the philosopher Heraclitus already referred to as enantiodromia, ultimately reveals the profound nature of our reality, a fractal quantum universe, constantly in dynamic equilibrium between order and chaos.